You've heard of them, right? Black holes. They're these cosmic monsters, these places in space where gravity gets so strong that literally nothing can get out, not even light. But they're so much more than just giant vacuum cleaners. They're where the universe as we know it, space, time, all of it, gets twisted and warped into something we can barely even imagine.
So let's just dive right into the big one. What if we could actually do it? What if we could take this wild thought experiment and send someone on the ultimate one-way trip? What would they actually see? What would they feel? And maybe just as important, what would we see watching it all happen from a safe distance?
And to even begin to wrap our heads around this journey, you gotta start with one simple fact, put perfectly here by Sir Martin Rees. A black hole is basically what happens when gravity wins. It wins against everything else, crushing matter so intensely that the normal rules of the universe just, well, they just start to shatter.
So this whole story, it's really two stories in one, and they couldn't be more different. First, there's our perspective, watching from the outside. And then there's the story of the person who actually takes the plunge. What they see and what we see are two totally different realities. It's kind of mind-blowing. Okay, let's put ourselves in the safe spot first. We're watching from our spaceship, light years away. As our brave astronaut gets closer and closer to that point of no return, something incredibly weird starts to happen. It's a trick of light and time so strange that it actually gave black holes their very first name. You see, Einstein figured out a century ago that really massive things don't just bend space, they bend time too. And a black hole? Well, it's the most massive, most compact thing you can possibly imagine. So its gravitational pull doesn't just tug on things, it literally starts to stretch and slow down time itself.
And here's what that looks like to us. This is something called gravitational time dilation. As we watch our astronaut get closer to the edge, the event horizon, we'd see the clock on their wrist start to tick slower and slower. And as they get right to the very edge, from our perspective, their clock just stops. It looks like they are frozen in a single moment for all of eternity. And it isn't just time that's getting all warped. The light itself, the very light that lets us see the astronaut, is fighting an impossible battle against gravity to reach us. This epic struggle stretches the light waves out, shifting them down towards the red part of the spectrum. So their image would get redder and dimmer until eventually they just fade away completely. And this whole crazy visual, well, it actually led to the first name for black holes, frozen stars. Two theorists, Zeldovich and Novikov, came up with it, and it's perfect, right? It's exactly what you'd see, someone or something just frozen forever at the edge of this dark abyss. A permanent ghost on the horizon.
Okay, so from where we're sitting, our astronaut is basically a statue. But what about them? What are they seeing? Let's switch perspectives. Now we're going on the ride. We're about to cross that invisible line. You know, Stephen Hawking had the perfect way to describe this moment. Think about being in a canoe near Niagara Falls. For a while, you can still paddle away. But once you cross that edge, the current has you. You're going over. The event horizon, it's the universe's ultimate waterfall.
But, and this is maybe the wildest part of this whole thing, for the astronaut, nothing, absolutely nothing special happens. Their clock is ticking normally. There's no wall, no beep, no sign that says point of no return. They just float right across this invisible line, probably without even realizing they've just sealed their fate.
Now, a little bit of advice if you're planning a trip like this. The size of the black hole you pick, it matters a lot. If you fall into a smaller stellar mass one, the gravity at its edge is so steep that it would pull on your feet way more than your head. It would stretch you out like spaghetti. Yeah, they literally call it spaghettification, and you'd be torn apart before you even got there. But a supermassive black hole? It's so huge, the gravity at the edge is much gentler. You could drift right across, totally unharmed. Okay, so our traveler has made it past the event horizon. For now, they're okay. But this is where reality just completely flips on its head. This is where space and time decide to, well, swap jobs. This is it. This is the new law of physics for our traveler. Every direction, up, down, left, right, every single possible path they could take now leads to only one place, the center. The singularity isn't a location you can avoid anymore. It's their future. It's what's going to happen. Okay, let's really break this down. Because if you get this, you get the whole mind-bending reality of being inside a black hole. Right now, out here, you can move any which way you want in space, right? But you can only move forward in time. You can't stop Monday from coming. Inside the black hole, that flips.
Now, you are forced to move in one direction in space, inward. That inward direction becomes your future. You can no more stop yourself from falling to the center than you can stop yourself from aging.
And if you're wondering why escape is so impossible, this is it. It's not about how fast your spaceship is. Inside the event horizon, space itself is falling inward, faster than the speed of light. It's like being on a conveyor belt that's moving faster than you can possibly run. It doesn't matter what you do. Space itself is carrying you to your doom.
So there's no way out. We know where this journey ends. With every tick of our astronauts' watch, they're getting closer to the center, closer to the end of their trip, and, well, the end of everything as we understand it.
And at the very, very center of all this is the singularity. That's not just a fancy word for something really dense. It's a point, a one-dimensional point where our understanding of the universe completely breaks. It's where density becomes infinite, where space-time curves infinitely. It's where space and time end.
Just try to picture what this means. It is the absolute end of the line. All the matter, every star, every planet that's ever fallen in is crushed down to the single point of infinite density. Gravity becomes infinite, and all the laws of physics that we know and love, they just stop working.
And let's be super clear. Hitting the singularity isn't a risk. It's not a maybe, because it's no longer a place in space, remember? It's a moment in time. It is the final, unavoidable second on our traveler's clock.
Which, of course, leaves us with the biggest question of all. If our science breaks down, if time itself comes to a halt at the singularity, what happens then? What comes next? Is it just an end? Or is it something else? A new beginning? The honest answer is, we have no idea. And that mystery might just be the most fascinating thing in the entire universe.